How's it, grade 11s? Today we're going on to solving equations by using the quadratic formula. Okay, so this is your quadratic formula right over here. This thing will be given on your formula sheet. Okay, now this is important. Whenever we use this formula, you must have your equation in this form. Okay, ax squared plus bx plus c equals to 0. You must have it in that form. Once we've got it in that form, we can use this formula, which I'll show you in examples coming now. Okay, now what I want to talk about now is nature of roots. Now, the nature of roots is this b squared minus 4ac. And where we're getting that from is we're getting it from our formula over here. And it's under the square root, this b squared minus 4ac. Now, depending on what this b squared minus 4ac comes out to be, we can either take the square root of it or we can't. Okay, and that helps us decide what the roots are going to be. Now, when they say roots, all they mean is that your x values. You know, when you solve for it, you say x equals this or x equals that. That's what roots are. So it's your x equals or x equals that bit. And what we can do is we can describe those roots by using this nature of roots over here. Now, whatever's underneath that square root, that b squared minus 4ac, if it comes out to be greater than 0, okay, the equation has two distinct real roots. So you'll have something like x is equal to 3 or x is equal to 8. They're two different roots. Okay, now also just remember that we call this thing delta, okay, or discriminant. Then, if this thing comes out to be 0, the equation has one real root or two equal roots. And guys, you've seen that before when you get like x is equal to 2 or x equals 2. They come out to be the same root. Now, if this thing comes out to be a negative, okay, there's no real roots. Why would that be? Because if this comes out to be a negative over here, you cannot take the square root of a negative number, okay? And that's why there are no roots, or in other words, no x values, okay? If delta is a perfect square, then the roots are rational. So, for example, if this comes out to be 9, the square root of 9 is 3, so we can take that. But, for example, if it comes out to be 7, well, you can't really take the square root of 7, so it won't be rational roots. It'll be irrational roots. Okay, so let's have a look at the first example here, where we have to solve for x. Okay, so that's what we have there. Now, just remember, we have to get it in the form ax squared plus bx plus c equals to 0, okay? Now, your a is always the value in front of the x squared. So this is ax squared plus bx plus c equals to 0. And we have it in that form. So what is our value in front of the x squared here? It is 1. So we know that our a is equal to 1. Over here, the b is in front of whatever the x is. So here we've got minus 19. And our c value is the constant, which is minus 5. Okay, so our formula is x is equal to minus b plus or minus b squared minus 4ac all over 2a. All I'm going to do is substitute these values into the formula. So we get x is equal to, let's move this up for you guys, x is equal to minus 19 plus minus 19 squared minus 4 minus 5. So all I've done, just substitute my a, b, and c into the formula. Now what I'm going to do is just simplify this. So we get x is equal to a minus and a minus is positive, plus or minus. This I'm just going to plug on the calculator quick just to see what it is. So we get minus 19 squared minus 4, minus 5. And we get the square root of 381 all over 2. Now what I can do is now I can split it. Okay, so we can say here now that x is equal to 19 plus the square root of 381 all over 2, or x is equal to 19 minus the square root of 381 all over 2. And I'm going to work out these separately. So our first one is 19 plus the square root of 381 all over 2. And what I'm going to do is I'm going to round it off to 2 decimal places. So we get x is equal to 19,26 is the 1. And again, guys, you can see that this is going to be irrational roots because 381 is not a perfect square. The next one I'm going to do is this 19 minus the square root of 381 over 2. And round that off to 2 decimals, we get minus 0.26. Okay, so this is a nice easy way to help you factorize something if you can't factorize it in your head. Right, let's have a look at example 2. Okay, so example 2, we can see that it is definitely not in this form. Remember, we need to have it in this form: ax squared plus bx plus c equals to 0. So what I'm going to do is I'm just going to take the 8 to the other side, or the 8x squared to the other side, and then just rearrange this so it's in descending powers of x. So we get here minus 8x squared plus 4x plus 1 equals to 0. So now that is in that form. So now what I can do is I can just use my formula. Remember that this is ax squared plus bx plus c equals to 0. So our a value is equal to minus 8, our b value is equal to 4, and our c value is equal to 1. Again, grade 11s, this formula is given to you on the formula sheet, so you don't have to memorize it. Okay, so I'm just going to substitute my a, my b, my c in here. Okay, I'm just going to simplify here. Just want to see him. Okay, we just want to simplify here now. So minus 4 plus or minus the square root. Just do this on the calculator, see what it is. So we've got 4 squared minus 4 minus 8 and 1. All over minus 16. Okay, now I can split it. So x is equal to minus 4 plus the square root of 48 all over minus 16, or x is equal to 4 minus the square root of 48 all over minus 16. Plug this in the calculator. All over minus 16. And I'm going to round this off to 2 decimals, so we get x is equal to minus 0.18. And over here we will get x is equal to 2 decimals. And there's our solutions. Okay. Right, grade 11s, what I would like you to do is exercise 2.7 for me, please. Thank you.